Hi, welcome back to my channel. Okay, so today I'm going to explain to you on how to calculate the mode of binomial distribution. Okay, as you already familiar with the terms mode, as we already learned in our chapter 1 on data description. Okay, so mode is referring to the value of x which give you the highest probability. Okay, the one with the highest probability. So how are we going to find out how to determine your mode from the calculation? Okay, so first there are two different steps. Okay, two different working solutions that you can use to determine your number of modes. Okay, for example, the first one you may have you can calculate the values of the probabilities for different values of x, and from that you find out which x has give you the highest probability values. Okay, but this method is limited to small samples. Okay, means small numbers of trial for small size of experiment. When we have larger experiments, it is advisable to use method number 2, which I'm going to introduce to you in this video. Okay, so this method number 2 involves a special kinds of formula. Okay, instead of calculating one by one, we're going to compare the probability for when x equals to x with when x equals to x plus 1. Okay, so let's do for example 1. Okay, so it's p x equals to x plus 1 over p x equals to x, okay, which is actually equals to n minus x over x plus 1, okay, and this one we multiply with p and this one we multiply with q. So this is the given formula, and we need to substitute the formula with the corresponding values. Okay, let's look at the questions. So here is the representative of your binomial distribution. Okay, so number 10 is actually referring to n, and 0.8 is actually referring to p. As you already know, n is for number of trials. Okay, so p is the successful outcome, and your q is your failure outcome. Okay, so how to calculate q? So q is just simply 1 minus p means 1 minus 0.8, and for this one is 0.2. So that is your q. Okay, now let's substitute into our formula. Okay, from using this formula with the values of n, p and q that we already have. Okay, so p x equals to x plus 1 over p x equals to x equals to our n is 10 minus x, and then multiply with our p, which is 0.8 over x plus 1 and 0.2. Okay, so that's it first, and then we're going to come up with a statement. If p x equals to x plus 1 is greater than p x equals to x. Okay, so your p x equals to x plus 1 is equal to this one. Okay, at the top, the one that I already highlighted with the yellow color. So it's actually 10 minus x 0.8. Okay, is greater than, okay, for your p x equals to x is equal to the one that I already highlighted with the blue color. Okay, so let's write it. X plus 1 multiply with 0.2. So what's next? We need to expand the one in the bracket. Okay, expand at both sides. Okay, so leave it me with 8 minus 0.8x greater than 0.2x plus 0.2. Okay, so we're going to rearrange this equation so that I have one numbers at one side and x at another one side. So what I'm going to do, I'm going to move my negative 0.8x to the right, and I'm going to move this number 0.2 to the left. Okay, so it becomes 8 minus 0.2 is greater than 0.2x plus 0.8x. Okay, So 8 minus 0.2 is equals to 7.8. Okay, is greater than 1.0 x. So from here, I'm going to calculate what is my x. So 7.8 is greater than 1.0 x. Therefore, my x is actually 7.8 divided by 1.0, which is x is less than 7.8. So we get these inequalities. Okay, so how we determine modes from this? Okay, now we have not yet done with calculating our mode. Okay, so let's write a statement. Okay, so according to the inequalities that we write here, so we state that when x equals to x plus 1, okay, so the probability is greater than x equals to x, and we get our x to be less than 7.8. Okay, so if we calculate the mean for this one, okay, so I'm going to show you mean, okay, equals to NP, which is 10 multiplied with 0.8, so it equals to 8. Okay, so your mean is greater than your value of x given here, or the value of x that you already calculated before. So it's impossible. Okay, so your mode should be greater than your mean. Okay, so therefore we need to reverse the direction or the sign of your inequalities in this first statement. Okay, so let's rewrite. So initially, so we have px equals to x plus 1 is greater than px equals to x. And in this one, we get x less than 7.8. Okay, so we have to reverse the sign. Okay, if p x equals to x plus 1, okay, instead of greater than, we make it less than. So p x equals to x, where x it will become, so when we reverse the sign of this, we're going to reverse the sign for x as well. So x become greater than 7.8, and this become logic because our mean is 8. Okay, so it's more realistic. Okay, so therefore, okay, so the closest number close to x is 8. Okay, so p x equals to 8 is actually greater than px equals to x plus 1, so x equals to 9, greater than px equals to 10, and so on. Okay, therefore, it does px equals to 8 has the highest probability. Okay, mode is actually x equals to 8. Okay, so let's move on to another example so that you can have a clear understanding on how to calculate your mode. Example 2. A random variable x is binomially distributed with mean equals to 2 and variance equals to 1.6. Find mode x. So in this one, they don't give you what is the value of n, what is the value of p, what is the value of q. Okay, so therefore, by the given mean and the variance, you need to find out first what is n, what is p, and what is q, and then from there only you can determine the mode. Okay, so first, let's solve for n, p, and q. So your mean, okay, so mean equals to np equals to 2. Okay, your variance x equals to npq equals to 1.6. Okay, to solve this, I want to change the q into the terms of p. As we all know, p plus q equals to 1, therefore q is actually 1 minus p. Okay, so this is 1, this is 2. I'm going to substitute first equation 3 into 2. So it becomes, okay, np 1 minus p equals to 1.6. So let's expand this one. Okay, it becomes np minus np squared equals to 1.6. Okay, so this one becomes a new equation. So let's rename it as equation 4. Okay, how to solve this one? Okay, so I'm going to divide equation 1 with equation 4. So EQ1 over EQ4. Okay, so my equation 1 is 2 equals to NP, and my equation 4 is 1.6 equals to NP minus NP square. So I'm going to simplify 2 divided by 1.6, so it becomes 1.25. Okay, so equal. And for this one, okay, I'm going to take out and remove n, since n is present at both numerator and denominator, as well as p. Okay, so take out np first, np. So first one might multiply with 1. Okay, at the bottom, so np is actually equals to 1 minus p. So leaving us here with 1.25 equals to 1 over 1 minus p. Okay, so I'm going to multiply 1.25 here with 1 minus p, so that I can calculate what is my p. So 1.25, 1 minus p equals to 1. Okay, as usual, expand. So it becomes 1.25 minus 1.25p equals to 1. I'm going to move my 1.25p to the right side, so you got positive, whereas my number 1, I will move it to the left side. Okay, so it becomes 1.25 minus 1 equals to 1.25p. So leaving me with 0.25 equals to 1.25p. So in order to get my value of p, so 0.25 divided by 1.25 equals to p. Therefore, my p is actually equals to, okay, so you have to press the calculator. So your p is equals to 0.2. Alright, so since you already calculate what is p, now you can determine what is your q, which is your q is just simply 1 minus p, 1 minus 0.2, which is 0.8. And your n, we can use either equation 1 or equation 2 or any of the equation here, 3 or 4. So I'm going to use equation 1 to get my n. So mean np equals to 2. Okay, so my n multiply with 0.2 equals to 2. Therefore, my n is actually 2 divided by 0.2 equals to 10. Okay, so that is the value that we get. Okay, so here is our p, 0.2. Our q is 0.8 and our n is 10. So we already have all the required information for us to determine the mode for this question. Okay, so our mode, okay, so we're going to find out what is our mode. Okay, so we're going to use this formula, p x equals to x plus 1 over p x equals to x equals to p, okay, n minus x over q, okay, over q x plus 1. To substitute into the formula with the correct value, so p x equals to x plus 1 over p x equals to x equals to, our p is 0.2. Okay, our n is 10 minus x. Okay, and then our q is 0.8 and x plus 1. Okay, so let's write the statement. If p x equals to x plus 1 is greater than p x equals to x. Okay, so I'm going to substitute the inequalities with the correct value from the formula that we used before. Okay, as you know, when p x equals to x plus 1, we have this equation. Okay, so it becomes 0.2 10 minus x, okay, is greater than when p x equals to x. Okay, so the equation is this, 0.8 multiply with x plus 1. Okay, what's next? We're going to expand, okay, the equation. So expand here, expand on the left as well, on the right as well. Okay, so it becomes 2 minus 0.2x is greater than 0.8x plus 0.8. Okay, so I'm going to move the x and the numbers to one side. So I'm going to move this negative 0.2x to the right, whereas the 0.8 I'm going to move it to the left. So it becomes 2 minus 0.8 is greater than 0.8x plus 0.2x. So 2 minus 0.8 is equal to 1.2 is greater than 1.0x. Therefore, your x is less than 1.2. Okay, so that is the inequalities for the values of x that you get. Okay, so we have not yet settled down because we need to find out what is the mode. Okay, so we need to find out what is our mean. So mean equals to 2, which is, as given in the question, which is larger than this x that we obtained here, which is less than 1.2. Okay, so that means we have to reverse the equation. Okay, so we have to reverse this equation. If px equals to x plus 1 is greater than px equals to x, we will get that 1.2 is less than x, or your x is less than 1.2. So we need to reverse this one to satisfy with the mean that we already calculated before. Okay, so how to reverse the sign? Okay, so it becomes, if p x equals to x plus 1 is greater than p x equals to x, we will get our x to be less than 1.2. But mean equals to 2. Okay, therefore we need to reverse this whole thing. Okay, reverse all the sign. So it becomes then, okay, so p x equals to x plus 1. So if it's greater here, it becomes less than p x equals to x. So our x now, instead of less than 1.2, it becomes greater than 0.2. So it's satisfied with our calculated mean, which is equals to 2. So x equals to x plus 1 is less than px equals to x, and our closest numbers to 1.2 is 2. So p x equals to 2 should be greater than any numbers bigger than 2. So p x equals to 3, but greater than p x equals to 4, and so on. Okay, so therefore when x equals to 2 has the greatest probability, so p x equals to 2 has the greatest probability. Okay, therefore x equals to 2 is the mode for this equation, mode for this question. Okay, so this is the final example for this one. It's quite difficult, but I hope that you can digest it. Okay, please replay this video, pause it, or slow down the video so that you can understand better about how to calculate your mode. Okay, like I already told you, if your sample is very small, like less than 5, you can calculate the probability for every x value manually using the formula. Okay, using the formula NCX multiplied with PX multiplied with Q n minus x. Okay, so method number 1, calculate the probability for each x value starting from 0 to number of trials. Okay, in your sample. If it's 5, so that means from 0 to 5. Okay, so from there, determine the value of x. The value of x with largest px equals to x value. Okay, so x is your mode. Okay, so this is the alternative method, okay, to the method that I discussed with you in this 2 different examples. Okay, thank you for watching. See you guys in my next video. Bye bye.